way of measuring the rate of a reaction is to look at how quickly the products are formed. The reaction between hydrochloric acid and sodium thiosulfate produces a suspension of solid sulfur. As more sulfur is produced, the solution becomes cloudy. At some point, the black cross will no longer be visible. It's a simple way of monitoring the rate. The quicker the cross disappears, the quicker the reaction. To measure the rate more accurately, you can shine a light through the solution and use a light meter to measure exactly how much light passes through it. The amount of light reaching the meter is already falling. As the sulfur is produced, more light is absorbed by the reaction mixture and less light passes through. The meter reading continues to fall. The reaction is over when the amount of light reaching the meter remains steady. A data logger captures all this information. Attach it to a computer and the results are represented graphically. The amount of light passing through is plotted against time. It produces a curve that eventually levels off when no more light is able to pass through the cloudy sulfur. The concentration of the acid was 1 molar. So what do you think will happen if it's increased to 2 molar? Once again, the data is collected and a graph of light passing through the solution is plotted against time. It's still a curve, but this time the curve is steeper. The sulfur has been produced more rapidly. The rate of the reaction has increased. For a chemical reaction to take place, the reacting particles must collide with each other. On the right, the yellow reactant is doubled and the collision rate increases. Decrease the concentration of hydrochloric acid, and what do you think will happen? With this reaction, the initial mixture is at a room temperature of 25 degrees C. It's colourless, but the moment that one of the reactants is used up, it changes suddenly to deep blue-black. It takes just 21 seconds. At 35 degrees C, the reactants are now 10 degrees warmer. What do you think will happen? This time it takes just 11 seconds. When the reactants are now just 15 degrees C, how long will it take? How might increasing or decreasing the temperature be affecting the number of successful collisions?